My name is Stephen Tramer. I'm here to talk about overloaded and custom operators in Swift while you guys finish lunch. I am an employee of AOL, which, to answer your immediate questions, yes, it still exists. Yes, we still have dial-up. No, you cannot get 300 free hours. I'm giving this talk because of two reasons. One of them is I was a mathematician in another life, and I studied group theory and number theory. I did not study operator theory, but I came close. And I also was a C++ developer for many, many years. And if there's one thing that C++ developers like to tell you about, it's how bad overloaded operators are. So, not going to be a lot of Swift code in this talk. This is like a theory talk. It's a talk that's encouraging you to ask some questions about operators. So, let's do some theory stuff first. Some of this stuff is probably going to sound confusing because it is all math stuff. An operator is just any function, f, that takes a Cartesian product from different sets and produces a result in the range. A function that takes n elements is an operator of arity n. And generally, we care about, as programmers, unary, one argument, or binary, two argument operators. We want them to be pure functions. If you're not familiar with what a pure function is, it's a function with no side effects. We can argue about what a side effect is. For the purposes of an operator, a side effect means that the operator does not change any state at all. All that it does is it returns a value. Nothing is modified. Of course, we also have the ternary operator, which nobody overloads and exists because of the 1970s. Generally, operators are syntax sugar for us. This has become more and more obvious as time has gone on. In C, you have equal AB. Okay, A and B are equal. In object-oriented languages, you have A is equal B. And now with operator overloading, we have A equals B, where that equality operator in there is actually just a function. What are some examples of real-world operators? When we talk about operators, generally we're talking about things that happen in the real world, that have a concrete mathematical or intellectual definition. Like string concatenation is something I'll talk about in a little bit. That is a real-world operator. Multiplication, we all know this one. You take two real numbers and it produces a real number. Dot product. If you've ever done 3D math, you're familiar with this. It takes two input vectors from a vector space of the same size and produces a single real number. Through code that I did not typeset in LaTeX, but you can absolutely do that yourself if you'd like. It's essentially a sum of the individual elements multiplied together. And then there's matrix multiplication, which I'm not going to bother defining, but it takes an n by m and an m by n and produces an n by n. This is just one example of it. So they don't actually, the n's don't actually have to match up. I just did that there. Okay, more about real-world operators. These are all expressed with the same symbol. They're all expressed with the multiplication symbol. They all have different domains, which is the input values, ranges, which is the output values, and they also all have different implementation details. Multiplication of two real numbers, multiplication of vectors, multiplication of matrices, they're all different. They can all be defined in terms of earlier operations. This is actually an important mathematical concept, starting with the axioms of set theory. Addition leads to multiplication, leads to dot product, leads to matrix multiplication. You can define these in terms of each other, which is a nice mathematical property. But they also all have different mathematical properties. Multiplication and dot product are commutative, which if you remember high school algebra, commutative just means that you can swap them. A times B is B times A. Matrix multiplication is not associative. If you remember linear algebra, matrix A times matrix B is not the same as matrix B times matrix A. In fact, it may not even be possible to do that multiplication. Matrix multiplication is also what we call left associative. You start with the value on the left, you multiply it by the value on the right. If you, well, what I should say is you have A times B times C, A times B times C. There's a good summary of the rules there, of what left associative actually means. And when you talk about custom operators in Swift, you actually have to define the associativity of an operator. So this is an important thing. All right, now we can actually talk about the Swift stuff, about overloaded operators. So the solution to identical syntax for different operations on different objects. We want to be able to multiply integers. We want to be able to multiply floating point numbers. We want to be able to multiply structs or classes, whatever. If you look at the Swift source code, you will actually see that the operators for integers and floating points are defined as part of those classes. And those classes just happen to be what are called raw representable, which means they can be represented in terms of a finite number of bits on the processor. Use with care and caution. I'm going to talk a lot about this. I have a serious problem with operator overloads that are used by people who are not very familiar with operators, which is the whole point of this talk, because I got a lot of questions about this kind of stuff at work once. Overloaded operators come with a predefined arity and precedence. Multiplication operator is always commutative. It does have left arity according to the Swift system. And the precedence is, it has a higher precedence than addition and subtraction, but it has a lower precedence than some other operations, I think. There's an enormous list of the precedents for each different built-in operator that you can get. There are like 40 of them, so I didn't really feel like putting that chart in here. Swift operators you can overload are left associative, all right, I went over that. All right, so overloaded operators. Now let's talk about the problems with overloading operators. This is the classic C++ problem. We have a value A of type T, a value B of type V. Let C equals A plus B, let D equals B plus A. What is the type of C? We don't know. Can't even click on the little plus symbol in Xcode. You can't option click there to get the definition of what that operator is. You just won't do that. Whether or not that's an Xcode bug is up to you. But also, you probably don't want to click on every single operator in your code to find out what it does. What is the value of C? I don't know. I'm assuming that it's something meaningful for addition of these two types that are not the same type, but maybe it's not. It could actually be like a file output thing. Like if A is a file handle and B is a string, it could write B to a file and return the file handle. Could do that. Are C and D the same? I don't even know if they're the same type, because I switched the order of operations, which means that the actual function that was applied is different, because the arguments were different. The left-hand side and the right-hand side were different. So that's the classic C++ problem that every C++ developer you have ever talked to said that's why they say overloaded operators are bad. Of course, nobody would actually do this, right? No one would ever, in a million years, define plus to be like a file concatenation operation, except when they do. Go ask seriously, ask a C++ developer who was working in C++ like between the years of, I don't know, like 1983 and about 2005. They will have a horror story for you, 100% guaranteed. Swift mitigates this problem. They have custom operators, so you can define your own operator, so you don't have to have plus mean for file concatenation. If you really, really need that, you can make your own operator and like make it kind of goofy or something. Has Unicode support. There's actually a subset of Unicode symbols you can use as operator names, which is kind of nice. Most of them are mathematical symbols, but there are a couple other ones that I'll get to in a bit. Now let's talk about what you should overload. If you're thinking about overloading an operator instead of creating a named function, what questions should you ask yourself? Is it a well-defined mathematical operation? This includes things like string concatenation, right? String concatenation, as far as a programmer is concerned, is a mathematical operation. It brings two contiguous areas of memory together, like at the lowest possible level, if you really want to think about it like a C programmer would. Seriously, mathematical operations only. Don't use operator overloads for anything else. And extra seriously, only use a well-defined operator. There are poorly defined operators in mathematics. It's very unfortunate, but true. I don't have an example of one because the last time I thought about this stuff was about somewhere between 10 and 13 years ago, and also they're all like super weird. However, C++ has a fantastic real-world example for us. They use the bit shift operator as writing to a file handle. It is what I would like to call a worst operator. It's not mathematical, and it's not particularly well defined. For example, the behavior of, what happens if I can't write to this file? It's not really specified very well. All right, when you should overload. Real questions now. What is your product? Am I building a library? Am I building an application that my entire team will work on? Am I building something that only I, as a weird person, will only ever look at on my own? If the answer to the last thing is, I'm only going to look at this myself, and I'll remember absolutely everything about this product forever, overload whatever you want. Forget all of these rules. Just remember, you might have to look at it like 6 months later. You might hand it off to another person, or another person might want to help you. You might be working on like a library that gets distributed, an SDK or something. Who is your product for? This is especially important if you're producing an SDK or header files or an interface, anything that someone else will use where there's the possibility that they may email you to ask, what does this mean? If you think that your audience would not be comfortable with the way that you've defined an overloaded operator, don't do it. Is it completely unambiguous? All right, I have 2 complex number types. I can add and multiply and subtract those. Awesome. Division is a little harder. It can be a little ambiguous. You also have to make sure, how is it intended to be used? Is the audience of what I'm producing, like, is it actually mathematicians and programmers who regularly work with mathematical operations? People like, I don't know, graphics engineers? If it's not, if it's meant for like a really broad audience of just every average person on the planet who is just beginning to learn programming, maybe reconsider using an overload. Also, you need to guarantee consistency with expected Swift behaviors, which means respect the arity of your operator, respect the precedence of your operator, respect the fact that Swift built-in operators never overflow, respect how Swift built-in operators of the type you're overloading react to values like not a number or maximum values. Make sure that you understand the fully well-defined behavior of the operator you are overloading. And remember, if you don't want to overload an operator, it's cool to have a function that has a name. They do this in Swift, in the math library. There's a function called pow, which is the exponentiation function. Lots of languages have an exponentiation operator. They chose to use the word pow instead of an exponentiation operator because exponentiation operators actually make things more difficult to read, and lots of people don't understand how they work very well. So I'm going to also go over this real quick. This is a danger note. You can, in fact, redefine an existing operator implementation. That second line there, redefining what plus means for integers to always return the value 2, that's totally valid. You could do that. Your coworkers will think it's great. But implementations are functions, so they're scoped. Operator definitions, not necessarily scoped. I didn't look into this too deeply, but I imagine they are not scoped to modules. All right, there are 2 protocols that you're going to implement that will, well, 3 really, because comparable. But these 2 are actually pretty important. You're going to overload the equality operator for equitable and hashable. So make sure that you always ensure that A equals B if and only if B equals A. Always make sure that if A equals B, the hash of A equals the hash of B. Ideally, the converse is also true, but hash collisions exist. Sorry. For an example of what this looks like when it's done badly, this is JavaScript's equality table. This table is only symmetrical because they left off things like argument lists, which are sort of like an array, but not really, and also objects that have values associated with them. This is the nicest table I've seen for JavaScript equality in that not only does it cover a lot of stuff, it's also symmetrical. It really shouldn't be. All right, so now let's talk about custom operators. Custom operators, they solve a lot of these problems. It's great. It is Swift's solution to bad operator overloads. One of the reasons why C++ is so maligned with its operator overloads is if you want an operator, you have to overload an existing operator. You can't create a new one, which means that, yes, developers do end up using things like the plus symbol to mean weird things because they wanted it to be an infix. But also declaring an operator is different from defining an operator. It's actually a special keyword. the operator keyword. It's covered in the Swift programming language book published by Apple. They actually do a great job of explaining it. That book is really bad in some places. Explaining how operators work is actually not one of them. It's very good. Custom operators are difficult to create for a reason. And when I say difficult, I mean there's 2 steps to them. You declare the operator, but then also you define the operator. Declaration is this operator exists. Defining is this is the function that actually implements the operator. Now, questions you ask yourself, should I create a custom operator? Talk about the questions you ask yourself when you overload. These are similar. There are 2 very important questions, I think, though. One of them is, am I embedding a DSL in Swift, domain-specific language? I think that this is a questionable thing to do on your own, but you're perfectly welcome to do it. And then, am I writing a mathematics library? If the answers are no, you should probably not create a custom operator. Custom operators are confusing. You cannot look them up. Again, you can't option click on that thing and go to the source code, and there's going to be a big comment there explaining what everything does. If I am an end user of your product, and it's like a networking library, and it has a custom operator in it that is maybe, I don't know, like the ASCII the Unicode symbol for right arrow. I'm not going to know what the hell that means. It's probably going to be really important, though. But these are some questions that you might have in response to that, or statements, I should say. I want a function composition operator. Great, it's coming in Swift 4. Also, you found like the one legitimate thing that is a custom operator that everybody wants. It also happens function composition is a well-defined mathematical operation. So, follows all the rules that you would want to. I already talked about exponentiation. There's a function there. It's called a function. It's a function because it's easier to think about. If you really want to create an exponentiation operation, it's also a little more difficult because you have to worry about the precedence rules, you have to worry about the associativity, all that stuff. The last one here is one that, when I saw the Unicode symbol table of what you're allowed to use as an operator, I immediately thought of this, and then I immediately thought, this is the worst idea ever. You're allowed to use currency symbols as part of an operator, which means that you could theoretically create a left prefix operator that is a currency symbol that converts between currencies. That sounds kind of cool. That's also a really bad idea because no one's going to know what it means, and also, like, that's cruel. No one wants to type Unicode symbols. Please don't make those of us with Latin keyboards do it. Like, those of you who don't have Latin keyboards probably don't want to do it either. If you really do have to make one, here's the pages of the book that you want to read. There's only, like, I don't know, 10 of them, 10 to 15 pages. There's some stuff in the language grammar section that might also be good to read. All right, this is the most extreme of dangers. You can redefine what an operator is. I can, at any point, say that plus the infix operator, it now has right associativity, and it has the same precedence as multiplication. That takes place, that now affects everything in Swift. That is not scoped. This is an awesome way to screw with people. Don't ever do it.
Yeah, thanks, Stephen.
Okay, thank you.
Round of applause.